April 3, 2017. The Loy Lang Box Company of St. Louis, Missouri. One worker and 3 members of the public were fatally injured when a pressure vessel catastrophically failed, causing an explosion that launched the pressure vessel into a neighboring building. The Chemical Safety Board investigated and found that over the course of many years, an area of the failed pressure vessel had thinned due to a known corrosion mechanism that was poorly controlled at the facility. And the CSB found that Loy Lang repeatedly ignored clear warnings that corrosion was causing major problems within its operations. In fact, prior to its failure, Loy Lang ran the pressure vessel normally, despite knowing that it was leaking. It was a safety emergency that unfolded in plain sight.
The incident at Loy Lang resulted from a tragic series of circumstances: ineffective corrosion management, inadequate pressure vessel repair, a lack of inspections, and the absence of sound safety management systems. The result of those factors was that a severely corroded pressure vessel, which presented a serious safety hazard, was allowed to operate until it ultimately failed, resulting in the death of 4 people.
Loy Lang manufactured corrugated cardboard, which is used to make other products such as boxes and retail displays. Part of the process to make corrugated cardboard involved heating paper using a steam generation system. The steam generation system used municipal water. The water was fed into a vessel called the makeup tank. There, the water was treated with chemicals and heated to approximately 200 degrees Fahrenheit to remove dissolved gases, including oxygen. This was necessary because oxygenated water is corrosive to steel equipment. The water then flowed from the makeup tank into a larger pressure vessel called the semi-closed receiver, or SCR. The SCR was comprised of a cylindrical center and 2 end pieces, called heads. All 3 sections of the SCR were made of steel and susceptible to oxygen corrosion. The SCR was kept under pressure so that the water inside would retain more heat than it could at atmospheric pressure. From the SCR, the water was pumped to a generator that converted it to steam, which was used to heat the paper. The steam then cooled, condensed back into water, and flowed again into the SCR. At the end of the workday, Loy Lang operators shut down the steam generation system, leaving the SCR filled with warm water. At the beginning of the next workday, operators would restart the steam generation system. During the daily startup, operators would initially block the flow of water into the SCR from both the makeup tank and from the condensed steam returning from the corrugation process. At the same time, the water remaining in the SCR from the previous workday was pumped to the steam generator. As a result, the water level inside the SCR would drop from its normal height of about 14 feet to about 2 feet. When the SCR was nearly empty, operators would then allow water to flow into it from the makeup tank. Loy Lang's steam system was used to heat the water in the makeup tank. But at this point in the startup process, the water in the makeup tank may not have been effectively heated to approximately 200 degrees, so not all of the dissolved oxygen in the water was removed. Therefore, during startup, oxygenated water entered the SCR instead of the heated oxygen-free water used during normal operation. This presented a serious corrosion hazard within the steel vessel. Eventually, hot condensed steam returning from the corrugation process was available, and operators opened a valve to allow it to flow into the SCR, reducing demand for water from the makeup tank. But due to the design of the SCR, water did not flow easily through the bottom head. Operators could achieve flow in the bottom head by opening a manual valve and allowing water to drain from the SCR, a procedure known as a blowdown. But between blowdowns, a small volume of oxygenated water would remain trapped in the bottom head, and over time, the oxygenated water corroded the steel. The potential for corrosion was a known problem. During its time operating the SCR, Loy Lang experienced at least 3 leaks due to corrosion. In response to a 2012 leak, a repair company removed most of the bottom head. The company patched it with new steel, leaving the remainder of the bottom head in place. But the original steel of the bottom head that was left in place was also thinned from corrosion. And between 2012 and 2017, it continued to degrade and eventually started to leak. On Friday, March 31st, Loy Lang operators noticed a leak that appeared to be coming from underneath the SCR. A local welding company was contacted to assess the SCR, but was not available until the following Monday, April 3rd. Loy Lang continued operating the leaking pressure vessel throughout the remainder of the day on Friday and shut down the steam generation system as normal that evening. On Monday, a Loy Lang operator began the regular startup process around 6 a.m. At approximately 7:20 a.m., the vessel catastrophically failed. When suddenly exposed to atmospheric pressure, the water in the vessel flashed into steam, greatly expanding in volume. The result was a boiling liquid expanding vapor explosion, or BLEVE. The explosion launched the SCR from the Loy Lang building and into the air. It traveled 520 feet, crashing through the roof of a nearby business a block away. Other debris damaged a third building as well as a parked vehicle. 1 Loy Lang operator and 3 employees of the nearby business were fatally injured. During its investigation, the CSB found 4 safety issues contributed to the explosion at Loy Lang: uncontrolled pressure vessel corrosion, ineffective pressure vessel repair, gaps in pressure vessel inspection and regulation, and deficient process safety management systems. The first safety issue is pressure vessel corrosion. Oxygenated water in steam generation systems causes corrosion in steel and must be managed and controlled. But at Loy Lang, there was a history of equipment failures caused by oxygen corrosion in the steam system, and 3 documented leaks in the SCR, including the 2012 leak that led to the repair of a portion of the bottom head, 5 documented corrosion failures in other areas of the system, and numerous undocumented leaks in the makeup tank, enough for the company to replace the carbon steel tank with one made from stainless steel to attempt to address the issues.
We found that all of the corrosion failures occurred in components of Loy Lang's steam system that, when operated under normal design conditions, should have experienced minimal or no corrosion at all. This points to the fact that oxygen was not properly managed or controlled within the steam system.
For instance, the CSB found that Loy Lang steam system water routinely lacked sufficient concentration of chemicals called oxygen scavengers that are used to remove oxygen from the water. And Loy Lang startup practices likely introduced oxygenated water into the SCR daily. The result was that over time, uncontrolled oxygen caused corrosion that thinned portions of the bottom head of the SCR so much that the vessel catastrophically failed.
Loy Lang needed to adequately remove oxygen from its steam system water to prevent corrosion. But despite evidence of the hazard at the facility, the company did not take effective action before it was too late.
The second safety issue found by the CSB is pressure vessel repair. In 2012, the repair made to the bottom head of the SCR left a corroded steel ring in the vessel. The ring continued to corrode for 5 years until it failed on the day of the incident. The CSB found that this repair did not comply with regulatory code. The regulatory body with authority at Loy Lang is the City of St. Louis. The City of St. Louis Mechanical Code required repairs of pressure vessels to conform to code from the National Board of Boiler and Pressure Vessel Inspectors. The 2012 repair of the SCR was performed by a National Board R-Stamp holding company, which meant the company was authorized to perform repairs to pressure vessels in accordance with the National Board Inspection Code. But the CSB found that the repair did not adhere to that code, which generally requires that all defective material be removed. As a result, the 2012 SCR leak repair was ineffective, incomplete, and dangerous, and it was the unacceptably thin remaining material from that repair that failed, initiating the incident. At the time of the 2012 repair, National Board Code required the involvement of a repair inspector, but did not require specific inspection points during the repair process to provide quality assurance. Instead, the level of scrutiny applied to any repair was left to the individual inspector's discretion. In this case, the repair inspector approved the repair plan without first evaluating the SCR, and the inspector did not personally witness the inappropriate repair to the SCR bottom head. Had the repair inspector seen the repair in progress, the inspector might have detected and refused to accept the inappropriate repair, which could have prevented the incident. Since the 2012 repair, the National Board made significant changes to the code, requiring inspectors to designate inspection points throughout the repair process. But gaps still exist. For example, the code does not specify whether the repair inspector must make in-person contact or view the job prior to reviewing and accepting a repair plan.
Understanding the extent of damage to a vessel is a critical step for a repair inspector to make when determining whether a company's repair plan is acceptable. We believe that this step should be specified in the National Board Code.
As a result, the CSB made a recommendation to the National Board of Boiler and Pressure Vessel Inspectors to update their rules to include prescriptive elements in the inspection process that would prevent the acceptance of a non-conforming repair or alteration. A third safety issue found by the CSB is pressure vessel inspection and regulation. At the time of the incident, the St. Louis City Code required an annual inspection of boilers and pressure vessels by city inspectors. But during the lifespan of the SCR, Loy Lang never applied for an installation or repair permit, or otherwise registered the vessel with the city. Therefore, the city had no knowledge of the SCR and no means of proactively initiating an inspection. The CSB found that despite the regulatory requirement that the SCR undergo annual inspections, there was no record of a city inspector ever having inspected the pressure vessel. Furthermore, the city had not inspected the Loy Lang steam generators generally since 2010.
Unfortunately, the city of St. Louis missed opportunities to prevent this incident. Had the city performed more regular inspections of the Loy Lang steam system, it could have identified the unregistered SCR, sealed it from operation, and ensured its inspection, potentially catching the corrosion hazard before the vessel failed.
At the time of the incident, despite requiring an annual inspection by city inspectors, the city code offered no specific guidance on inspection methods or tasks beyond the annual frequency. The inspections were specified to be as thorough as circumstances permit. The City of St. Louis has since changed its inspection requirements to require that boiler and pressure vessel inspections be performed by an approved third-party agency rather than city inspectors. However, the city still has not adopted any specific inspection methods or tasks beyond the annual frequency, and neither city inspectors nor third-party inspectors are explicitly required to hold any inspection certifications, except in the case of certain boilers. As a result, the CSB recommended that the City of St. Louis Board of Aldermen revise the City of St. Louis Mechanical Code to adopt a national consensus standard, such as National Board Inspection Code Part 2, to govern the requirements for in-service inspection of boilers and pressure vessels, and revise the city's mechanical code to require pressure vessel inspections to be performed by a National Board of Boiler and Pressure Vessel Inspectors in-service commissioned inspector. Finally, the fourth safety issue the CSB found at Loy Lang was the lack of an effective safety management system.
To prevent this incident, Loy Lang needed to understand the hazards of its operation, implement and maintain safeguards to prevent corrosion in its steam system, and monitor those safeguards to ensure their proper function.
The CSB found that Loy Lang's management did not understand the hazards of its operation and did not see a leaking pressure vessel as a safety emergency. The company failed to prevent corrosion in the SCR, had no inspection program, never investigated or addressed the root cause of the corrosion in its steam system, and repeatedly operated the SCR while it was leaking, including on the morning of the explosion. Therefore, the CSB concluded that Loy Lang did not employ sound safety management principles in addressing the risks associated with corrosion in its steam system.
Had Loy Lang instituted elements of an effective safety management system, including mechanical integrity, incident investigation, and effective corrosion prevention programs, the hazard of corrosion could have been mitigated and this incident could have been prevented.
As a result, the CSB made a recommendation to the Loy Lang Box Company to develop and implement a comprehensive safety management system that includes elements recommended in industry good practice guidance publications.
Leaking pressure vessels can be dangerous and should be thoroughly evaluated to ensure that they are fit to operate. But even before a pressure vessel is compromised, there are many ways for companies to ensure that damage mechanisms, including corrosion, are properly understood and controlled. Doing so can prevent catastrophic incidents before they ever happen. Thank you for watching this CSB safety video.